Now, yesterday we had talked a lot about angles were always capital, sides opposite were always lowercase. So take out your homework. Come on. It's middle of February. You're a sophomore in high school. I shouldn't have to tell you date. Little n, little b, and little q. So you start with what you know. In this case, you are given a 65-degree angle, and you have the side of 10. It's a matter of labeling the parts from that information. 65 is my angle. That's my opposite. There's my adjacent, and there's my hypotenuse. Which means I have to find little q, little p, and angle n. What was it? Right. So I go through it, and in order to figure out what little q is, according to the angle that I'm given, that's an opposite. I'm given also an adjacent. What trig function uses opposites and adjacents? Tangent. So that means the tangent of 65 is little q over 10. Bring it over. Press the button. Thank you. Do the same thing with little p. I am given an adjacent. Little p is a hypotenuse. What trig function is adjacent and hypotenuse? Cosine. Over t. Now there, I have to do the exchange-o, change-o. And you get what for the hypotenuse? 23.66. 23.66. And like Whiskey said earlier, angle n is 25 because it's the complement to 65. Yes, ma'am. Well, if you're trying to use, we have the 65-degree angle. The side opposite is that little q. The side opposite the p is the hypotenuse. So we're given, according to this 65, it's adjacent. So remember, when we're going through this, sine is opposite hypotenuse. Cosine is the adjacent hypotenuse. Tangent is your opposite adjacent. So I know that I'm using an adjacent. So in my trig functions, which of these use adjacents? Cosine and tangent. I'm not going to use sine at all because I don't have any information in this problem to start with that have opposite or hypotenuse given this angle. Okay? That's why I always go with what information you're starting with, because it'll tell you what trig functions to use. And you're generally, since you're finding two different sides, you'll use two different trig functions. All right? That's how this stuff is going to work itself through. All right? Excuse me. Yes. Reuse your givens. Reuse your givens. Technically, here's the problem. If you're using a squared b squared from here, and you've already rounded off, you're going to have a rounding error to come back up here. Okay? But what happens if you got that wrong? Will you ever get that right? No. Reuse your givens. Yeah. Always, always, always reuse your givens. Okay? And the reason why you're off by a couple of decimals is because of the rounding error. Technically, it's not incorrect, but what if you accidentally hit, when you found your opposite, what happens if you accidentally hit sine by mistake? You'll never be right the second time. So you will always get two wrong, as opposed to, hey, if I reuse my given, I have a chance to get this right again. Okay, that's why there's a little ambiguity there. It's common for a trig like that, but just reuse your givens. Believe me, it will alleviate a lot of problems. Okay. Yes, sir.
So we should like always never use the 90 degree because it's like basically divided by 0, right?
Right. Because when you start thinking about it, if you have that 90-degree angle, when you start thinking about your trig functions, the sine of 90 would be opposite of our hypotenuse. Well, what's opposite the 90? The hypotenuse. So what's hypotenuse divided by hypotenuse? 1. Put in your calculator, sine of 90, what do you get?
1.
It's not 1.
If you do cosine, it's adjacent over hypotenuse. What's adjacent to your 90-degree angle? Do you know? You don't know. That's why it's error. And if I do same deal with tangent, opposite, your opposite over adjacent, you don't know which one's your adjacent. That's why it's also an undefined error. That's why we don't bother. You'll bother with your 90-degree angles in algebra 2, because in algebra 2 they're called quadrangles. 90, 180, 270, and 360. And they have specific values for which they oscillate.
So a diamond
No.
looks like a diamond.
Okay. Straddle. Wow. This is 14. Hey, you didn't do it. Get a piece of paper out and draw a picture. Yes, sir. It's on the board. It's online. It's all there for you. Yes, sir.
I've got a question.
Yes, sir.
So for side D, can we do c squared minus a squared?
Yes, and this is the case where you have two sides. Find the third. Find two angles. So you've got little d, little f, and little e. So yes, and this is the example in which you're going to want to use Pythagorean theorem to find that third side. So we need to find that third side, that little d. We need to figure out what angle f is, and angle d, excuse me. So if you start with your Pythagorean theorem, which of those three side lengths is your hypotenuse? 9. So we can just kind of say it's going to be d squared plus 3 squared is 9 squared. So d squared, 81 minus 9 is what? 72? Square root of 72 would be, what is that, 36 and 2, so 6 root 2. You get 6 root 2. Now, if it asks you to round to the nearest hundredth, which a lot of times it does, hit the double arrow, and you're going to get probably somewhere around 8-ish.
3 squared is 9.
14.
81 minus 9. Will be d squared.
Yeah. What was it? 849. Okay. So 6 root 2 or 8.49, and that's fine because your calculators, when you do this, will spit it out like that, and that's fine. Yeah. When it comes to the side lengths, if it gives you a thing where it says, excuse me, if it comes out as a radical, you can write that. Nothing. Now I go through it and I try to adjust to what I need to find as far as angles. If I start at angle F, I circle it. The information that I'm given is a side opposite and a hypotenuse. What do I use? Sine. So the sine of F is 3 over 9. Inverse, and you write it out. When you inverse inverse sine of 3 over 9, it's probably, I'm going to guess it's probably around 33, 34 degrees.
No.
19 point what? 5 something? 4.7. Okay. 2 decimals. And now if I go back and, again, instead of subtracting out, I go back and reuse my given, in case I accidentally did this wrong, I switch gears and I go to D. Now the relationship to the angle D, what is the 3? It's an adjacent. Is 9 changed from the hypotenuse? Nope. So
Cosine.
we use cosine. Very good.
Why can't we use the opposite of adjacent?
What if you were wrong? That's why I'm trying to alleviate the possibility of being wrong. Because it is totally possible, completely possible that you get this wrong, but you get these right. Okay? But if you get this wrong and you reuse this value, will you ever get these right? No. Reuse givens. Okay? So if you do that, you're going to get what? 7153?
Like, track 1.
Yeah, it's right in that neighborhood, so. Okay. And that's, or 750, was it 70? 70, excuse me.
And you are math teacher.
There you go from there. When you go through this, this is your generic setup, okay? This is your generic setup. I saw that you had this one. Do you know how to make sure that you're in the right mode on that one? Because you're getting different numbers on that. Yeah. Here's what's on. You're not doing this in correctly. These calculators have to default. So now let's go back. And that's the thing, if you what happens when you're not in the right mode, you're gonna get the exact opposite right.
Exactly.
You know, but here's the deal, if you write everything out correctly, I can say, well, that's not right, but it's you forgot, you're wrong. And that's all, and then I would know that, I would be able to figure that out. So that's why when I saw that calculator, I knew that you probably already knew. Because I saw your eyes were, something looked great. So that's what we're looking at. Bonjour. Again. Going back again. Going back again here. You'll see that you have, excuse me, you have one angle and one side, which means you got to find the other two sides and the other angle. So label out what you have and what you know. Little r, little t, little s. Whiskey. Come on, man. You are starting at the 57, which makes that side, it's what? Opposite. So I'm going to use this as, technically as my pivot to find the other two sides. Remember, when you have your trig stuff, if you have an angle and an opposite, you can find two values. An angle and an opposite will allow you to find a hypotenuse if you use sine. It'll allow you to find an adjacent if you use tangent. That's the idea of reusing given information to get through it. Okay? That's why we keep saying reuse given. So, as you fill this stuff through, I know that I have to find side T, side S, and angle T. How am I going to find side T? Is that an adjacent, hypotenuse, or an opposite? An adjacent. So, knowing that I have an opposite, if this is my adjacent, what trig function am I going to use to find that? Tangent. So the tangent, 57, is 15 over that little t. When you're at, remember, when you're at the angle, your angle always looks at your opposite. This never changes as the hypotenuse because it's across from here. So if I, that right up meant adjacent.
Oh, okay.
I didn't, no wonder why you're like, wait, I wrote down opposite, I'm sorry. So there, that helps. So then you go through, and when it's the variables on the bottom, exchange those changes. Press a few buttons. I feel really bad. I'm assuming your hands don't. It was a bad sickness one. I still felt it. And then to find the hypotenuse, knowing your opposite, what trig function is that? That's your sine. So then we use the sine. So our little s will equal 15 over the sine. It's so nice when they have s's and 5s and sines and stuff. It just makes everything so much easier to figure out.
It does.
Yes.
Angle T will be 33.
What's that?
Angle T will be 33.
Yes, and then the last angle, since you remember that your other angles in a right triangle are always complementary, the complement to 57 is 33. What'd you guys get for your decimals for those two? Just to double check it. 17.89 for this one?
Oh, no, that was the sign. And the other one's 9.7.
And remember, you can always go back and look at your triangles to see if that actually makes sense. Remember what we did last semester, very end of the semester. Smallest angle was across from the shortest side line. Largest angle was across from the largest side line. Well, 90 should always be across from the longest side line. Is 1789 bigger than 15 and 9.74? Yes. And go from there. Okay. That's what you're looking at being able. It's just to kind of. It's kind of hard to double check yourself a lot of times, but that's the easiest way to do this. All right. Yeah, go right ahead. This is the third one. And what happens here is that you need to be able to draw pictures and diagrams to be able to solve these style problems. So if I'm looking at this, it says a wooden beam is 24 feet long, leans against a wall, and makes an angle of 71 degrees with the ground. How high up the wall does the beam reach? Well, what would that look like?
Like this.
Yes.
Draw the wall,
Draw a wall.
and then it's 24 feet long.
The wall?
No, it's the whole, it's like the hypotenuse.
Okay, wait,
Stop.
hold on, I didn't have myself. And then the hypotenuse is 24 feet long, and then the wall, and then the angle is 71.
Yeah. Boom, man. Man.
Smart, I'm smart.
Okay. So what are you trying to solve for then?
So.
The height of the wall. Now, is the height of the wall the opposite of the angle, or is it next to it? It's opposite. So, if I need to find the opposite, what am I going to use?
Sine.
Sine. Again, it boils down from being able to draw pictures for so many of these things. going through there, what are you gonna do?
24,
24
9.
starts
There you go. What is it?
No. Yes. Oh, wait.
And that's the idea. That's a
No,
rather,
it's usually two
it's a
and
rather
They get it
steep climb up a ladder if you think about it. Yes, sir.
It's like rounded to 22.7.
Yeah, it is.
2 decibels. You want to keep consistent 2 decibels.
It's 74, not 70. It's 71.
It's 71.
Yeah.
Whoa, what?
You have did this for the first time?
This is
That
amazing.
was kind of
Whoa, technology.
Technology.
Why is this letting me zoom in? There we go.
Just had to make sure it's 70.
Yeah, just making sure.
Alright.
Oh, it looks like 74. What is
You still sure it's 71?
You guys ever saw that? Do you know you can do that?
that? No.
Really?
Yeah, none of the other teachers do it.
Yeah, none
Because
of
they're
the
not
teachers
smart.
are
Wow,
even
I'd
like-
rather the teacher.
All they do is click and play.
She's like, why is my screen purple?
Who's that?
I think I broke it.
Wow.
I think we have a tech guy the other day.
That's
I didn't see the backs, okay.
Well, remember, I think I've said this to you guys before. The math department, we were the ones that first got smart boards probably about 8 years ago now. I'd say maybe 7 or 8 years ago is when we first got. So we've been using smart boards longer than anybody else in the building, and it's kind of frightening that people still don't know how to use them.
It's funny. It's hilarious.
Yeah.
I think it's so funny.
I mean, seriously, I bet you anything that they wouldn't even know that I could say hello, and it would, well, it does that, but,
No.
or if I write,
Can't you like make your like into like actual like text?
You
yes.
can get a circle, right?
Wait, what about it?
Oh,
I was going.
I was like, that's it?
Yeah, no, I'm pretty sure half of them don't even use this one.
The calligraphy one, yeah, that was pretty cool. Let's see. I like this one. Number 4. A plane took off from a field and rose at an angle of 8 degrees with the horizontal ground. As the plane flies over a water tower, it had covered a distance from takeoff point of 2,000 feet. How far apart are the takeoff point and the water tower? So, as the plane takes off from a field, we need to have a field. We need to have a field. It's green.
Mine's great.
That's great.
Nice straight line.
And then we need to have a plane.
Everyone two fields. Just find out what's up. That's up to the flight.
Have 6 up.
Probably crash all
It'd be 17.
Sticks off. Oh no.
How can you?
That's a soft.
Anyway,
Mr. Murphy, I thought you was sticking off.
it's getting there. And then you have a water tower. I mean, it kind of looks right.
Then Mr. Murphy.
I put a little crow.
And barbs. Home with the barbs.
No, it's the Cal 100-year strong sign.
Listen to
Ah!
That's one bar. Okay, that's.
It just looks like that.
It kind of looks like a chicken.
It looks like a bird.
It does.
Anyway, so
Wall, it hits the top.
it's rising at an angle of 8 degrees. Quiet.
No one
And it has covered a distance from the takeoff point to the water tower of 2,000 feet. It's going this way.
Oh, yeah.
That's pretty bad.
Wait, what? I missed it. Can you go back? Wait.
I missed it.
If you just flick it and it bounces off.
You didn't know you could do that?
Yeah.
All right, anyway,
I did that.
the reason why it's saying that it's can travel 2,000 feet, if you're in an airplane and you're climbing, that's the direction that you're going. Because then the next question, it asks you, how far apart at the takeoff point and the water tower? You're trying to find the horizontal distance between here and here. The base, if you will, in this case. So, according to our diagram, that horizontal distance is what? It's the adjacent. It's the adjacent.
So
Oh,
you're going to use.
Because this is your vertical.
I thought you were talking about the 2000.
Bless you. So what trig function am I going to use to find my adjacent function?
Cosine.
The math of these problems really isn't all that difficult. It's being able to visualize it, and that's where it can get kind of messy.
It is actually kind of difficult.
So 2,000 cosine 8. What do you get for your horizontal distance? 1980.
19.5.
So somewhere in the middle of June of 1980.
Yeah. Pretty easy.
Nice. Mine was born 2 years before that. So she's 30. I'm gonna be 30. Miss Murphy, when were you born?
Before 1980.
What year?
Somewhere before 1980.
We'll do the math for you.
That's okay. I know how old I am.
1979.
Yo, don't judge him.
1971.
1979.
He just doesn't want to tell you because he thinks you're like, oh.
Find the measure of the angle of elevation of the sun when a vertical post 15 feet tall casts a shadow that's 20 foot. Yes, sir. Find the measure of the angle of elevation of the sun. So,
Oh,
Sunshine.
Sunshine.
Is it a line or a s-
it's a lion's.
Wait, you guys were talking to him?
it's the sun.
Wow.
The sun
Were you talking to me, Jason?
casts the shadow
How was he gonna tell me I was talking?
of a post that is, 15 foot tall post.
Should I be calling
It has a shadow that is 20 foot. Angle of elevation. Which angle am I looking for then? Am I looking for the one on the ground or the one up top? The one on the ground. Angle of elevation is line of sight up. Okay. Angle of elevation is line of sight up. Therefore, angle of depression is line of sight down. And this one you're going to use tangent. So, tangent theta and then again, as we're going to solve for theta, how do you undo tangent? You inverse. And that's going to give you your angle. Okay? 36.7 what? 8.7, 36, 8.7. Is it the end of the world if you don't put a degree symbol on something? No, not at all. Okay? Not at all. Now, what I want you guys to work on here tonight is that I just have a bunch of review stuff, both with the
And he's a whole bunch of
right triangles
Huh?
as well as
He's a
the
whole
elevation
bunch of
pressure.
like
Well, one thing I want to, guys, one thing I want to reiterate is the idea of your 30, 60, 90s again, because that's something we haven't done for a while. So that's just what we do this.
Tomorrow is a half day.
Yeah.
Way to get out of
So
Yeah, mine.
remember, you have special right triangles.
Somebody's at the door.
When you have special right triangles, those are your 30, 60, 90.
Oh, yeah.
And you had those two setups. Now, yeah, I just got lazy tonight.
Yeah, we're doing the entire thing.
What about this week?
Yeah, we got a couple of days to get through all of this. Yeah. So what I want to look at here is, take a look at number 5. Take a look at 5. 5 is which triangle, 30-60 or a 45?
36.
It's a 30-60. It's a 30-60 triangle, which means you have the ratio of your sides as that. You know opposite which angle according to the diagram. You know opposite the 90, very good. So I know opposite my 90 is equal to 4, which means that the side length 2 times something equals 4. Well, what does x have to equal? 2. Which means everywhere I see an x for the other 2 side lengths, what do I replace it with? And that's how we did these. It was a matter of setting up a possible one-step equation to get that constant value that's being multiplied through the ratios of the sides. All right. Same deal if I flip over and look at 7. 7 is also, well, this one is a 45, 45, 90. All right. Since 7 is a 45, 45, 90, you know opposite which angle in the 45, 45, 90. Well, we got to remember that we have the ratios where something, something, and something root 2. You know opposite which one? We know opposite the 90. Now, we know that opposite the 90 is going to be equal to 6, which means then I have a one-step equation to get x by itself. Now, remember, it's not bad to worry about it. This is x times the square root of 2. How do you undo multiply? Divide. Your calculators do that for you. You take 6 divided by the square root of 2. And you're going to get 3 root 2.
So for the 90, the x is 2.
Yep. When you divide that out, your calculator will give you an answer of 3 root 2 for the value of x. Which means, everywhere else I see the value of x, what am I going to replace it with? 3 root 2. That's the idea of using what's called simplified radical form. That's how you use that. Okay. Now, in here there's stuff that you would use for Pythagorean theorem. There's stuff of solving all parts. There's 8 of those like we did last night. There's a couple extra walk yourself through the triangle for 30, 60s, and 45s. Knock through as much of this as possible between this one and that elevation sheet, and we'll go over more of it tomorrow, and then be ready for our test on Friday. Yeah, we got a couple days to get through both those sheets. For the 6th time, I want you to do both of the sheets that I have given you, and you have basically 2 days to get it done.